Hello and welcome back. If you follow the channel, you know that our friend Marcel surprised us with a real Apollo DSKY. For those that don't know, the DSKY was the display and keyboard unit that interfaced with the Apollo guidance computer, and that you can spy in much of the footage of the Apollo missions. Like the guidance computer, it was very advanced for its time and featured a revolutionary solid-state flat-screen display, which relied on electroluminescent technology. Sadly, our DSKY has a badly broken display. I suppose it must have fallen out of somebody's pocket. Jokes aside, and to our great surprise, the display partially lit up when we tried it out in the previous episode. But we'd like to restore it to its former glory. Fortunately, Marcel had bought a spare display many years ago. Carl was able to relight it in 2021 while he was hiding in his lab during the worst of the pandemic, and it worked perfectly. Also, our DSKY has a yellow dot on it. That means that it has some kind of fold that makes it unsuitable for flight. And when we opened it up in the previous episode, we indeed found a module which had another yellow dot. We don't know yet what's wrong with it. We pick up from the last episode where we opened it up, repaired a few broken keys and removed the broken screen. Okay, so these are our three screens. A prototype one, a replacement one, and a broken one. And the simplest experiment would be to put the broken one on our setup back there because it's already ready to go. See if it still lights up despite the break. And as we just said, we plopped it into Carl's setup and it did light up. Amazing. Do you want to repair the DSKY with that one? And then we have to make a contraption to drive the DSKY.
Right.
So it doesn't really matter which screen we have.
And we gotta do something about that connector also.
Yeah. Our favorite Deutsch connector. Well, congratulations, Marcel. We have 3 DSKY displays. One with no cracks, one with a little crack, and one with a big crack. Yes, I forgot to mention that Marcel has yet another spare DSKY display. It's a very early prototype with a black enclosure and a small crack in a corner. Carl used it as the test guinea pig as he was developing his setup, and it lit up partially and somewhat unevenly. It was dimmer and much bluer, and we know that the development folks had to work quite hard to make it green and bright enough to be accepted by NASA. Finally, and quite amazingly, I should mention that our friend Ben Krasnow from the Applied Science channel not only made a heroic replica from scratch, but gave us his screen afterwards in case we'd need it. It's also bluer than the original, a closer match to the prototype, but what a feat! So lucky us, we have DSKY screens aplenty. But there's yet another layer of difficulty. Marcel's DSKY is an early one and they did some changes as they went along, so our good screen does not exactly fit.
The old style bezel and original style display.
Yeah.
And you can see how they fit nicely in here, just
that
like
works.
the one that was in here. This is our new display, which is serial number 346.
That's the one we had revised before we had on the display.
And the one that came out of here was serial 150 something or 30 something. So you can see there's an issue here with this screen protector they added. It doesn't fit now.
After Apollo 1 or something. Mike knows about it, right?
If we
Well, as you predicted, it doesn't fit.
Yes.
Yeah, right.
Yeah, so there's, if you take off these E-clips,
Yeah.
this front plate will come right off, and then it'll be the same.
Yep.
So it's just a clean add-on.
And it's interesting that it doesn't have any actual glass coverage. It just gives a little bit of
No, but
height relief.
there is glass on there.
Oh, there's an extra slate of glass under there
Yeah.
before the display.
Yeah.
Yeah.
Okay, so that's what it is.
Just don't break it again.
So we got all these parts off, the E-clips, washers, screw protectors. Now we're going to try to separate this bezel. It should come out pretty nicely. There it is.
So does it have an extra glass pane on it? On the unit itself, at least.
Yeah, it's affixed onto the front of the...
Yeah.
They
Yeah.
just basically
Okay, so that
stuck it
that
right.
should fit. So I would get the screws back, right, from the...
Let's see. We have two. There's a rounded washer, looks like, and a flat washer.
A few minutes later.
Ready for
Yeah.
reinsertion?
Hardware transplant completed. We took the bezel and all the screws off of that. And these are the jack screws from the original one, and we're going to use the other two straight screws at the top. And go ahead and try to plop this back in. Get our alignment there, and then start trying to crank her down.
And it's actually 4 jacking screws around the connectors and then 2 normal screws on the top.
Yeah.
Which makes sense because only the connector needs to be jacked
All the
off.
force is going to be right here.
Yeah. I have never seen anybody repair the DSKYs, by the way.
Nope. Only because the Deutsch connectors are so annoying.
Oh, but we know how to deal with that. We have Deutsch connector insert.
It doesn't make it less annoying, it just makes it something
Well,
possible.
so Mike is already anticipating our next challenge, making a connector to fit in the Apollo-only high-density version of the Deutsch connector. All right.
Okay, we're installed. That's a decently thick piece of glass on there.
Yeah, it is.
We're not letting that happen again.
I wonder how many times they broke screens before they decided to do that.
Yeah.
Precision parts. Nice.
Zero still works.
All right. We didn't break anything. All right.
Front's back on.
It's repaired. Okay.
Guess we should put the back on. So the only thing we didn't fix here is this little crack in the back. We can't pressurize it with nitrogen.
Oh, the little hole.
Okay.
So unfortunately the DSKY has a crack in the hermetic enclosure. This poor thing has been really beaten up, so we can't repressurize it with dry nitrogen. So did you guys figure out what the 115 Hz is for?
That's for the illumination on the buttons.
Yet another complication, the keys had electroluminescent backlighting, which required a variable high voltage AC power at 400 Hz, not 115 as I said mistakenly.
Okay.
All fixed. Excellent.
And,
Alright, so now we just need to power it up. Can you flip it around for the connector that we have to deal with? So yeah, so our next enemy here is the freaking connector, which fortunately happens to be similar to the one we have here.
Let's see what the CM
Is it or is it not? Let me see if our insert will work. Oh, yes, it's the same thing.
Nice.
Okay.
Moments later.
So you guys were able to do some connections?
Yeah.
Only 2
It's only 2 for now.
to
Only
start
needs
with?
2 wires apparently.
Alright.
Serial interface.
Okay, we start cautiously. And what are those 2 supposed to do?
So this is 5 volts caution power.
Oh, for
Which
the
are-
caution indicators?
Yes.
But we don't know if there's any caution indicator that will be lit.
We do, because we check the resistance.
Ah!
We don't know which ones are going to light, but
But there are some that are on.
seemingly.
Yeah, because this thing has memory because it has a latching relay, so it should power back up in the state it was on before.
All right.
Should we turn the light slightly off or
Yeah.
down? Two. There you go.
All right, so I'm going to start at 0.5 volts, and we'll look at the current. We'll probably not get a glow, but then I can slowly raise it.
Yeah, over there. Okay.
Okay. Yeah, getting a little bit of current flowing. 50 milliamps or so. I'm going to slowly increase the voltage.
I see nothing.
So that's 1 volt.
Nothing. You have 70 milliamps. Oh yeah.
2 volts.
Oh yeah.
We have a program alarm.
Program alarm.
Looks good.
It's a 1202.
The 1202.
All right, that's 4.2 volts.
Look at that.
Okay. Houston, give us a reading on the 1202.
Give us a reading on the 1202 program alarm. We're going that flight.
I wasn't expecting that color.
It's very yellow.
This is probably the most powered on a Disky's been in almost 50 years.
Yeah.
But we can do better.
That's a good start. You got the right pins, guys. So for the next bit, the same 2 wires, because you guys didn't want to rewire other ones, but different pins, and then we have a 800, not 800, 400 CPS, right?
Yeah, 400 hertz.
400 hertz voltage setup.
So we'll start at 0 and then we'll ramp it up.
So Mike and Eric decided to try the keyboard electroluminescent backlighting next.
No. Okay, so that's 10 volts. Getting up near 15. That's 20. Anything? It might be quite dim.
Yeah, I don't really see anything.
So we're trying to lit the keypad. Want to turn the lights off?
That's around 30.
I see absolutely nothing.
No. So we're at 30 volts now. I don't see anything.
Yeah, I don't see anything either. Pretty sure it's the right pins.
Yeah, we saw capacitance, but we saw very high impedance, which is what I would expect to see.
Yeah.
That's not
That's 40
normal.
volts.
That's not normal.
You want to go higher than 40, or
Hmm.
we should be seeing something now,
Yeah, we probably should be seeing something.
based on the range they specified. You said it was what, 20 to
20 to 75.
to 75? Okay.
Mike and Eric eventually got the keys to light up, but it was extremely dim. Mike caught that picture under a black cloth hood, using long exposure. Needless to say, our MIT lab DSKY had probably a lot of hours on the clock, and electroluminescent lights had a very short lifetime of a few thousand hours only, so that's probably why they are so dim now. The keys that didn't light up were the ones that got replaced with non-translucent material. Obviously, they didn't care about key lighting in the MIT simulator where this thing came from. 6 weeks later. So it's another day, and actually quite a few weeks later, and Mike has been working hard. What have you done, Mike?
I built a little board to interface to the DSKY. We were before just pressing pins into our little connector thing individually, which works for a couple of pins, but gets really tedious and hazardous if you're dealing with 50 pins.
But the board, you forgot to mention, the board has AGC on it.
Yeah.
So
this board looks like an AGC to the DSKY.
Right, so you have your AGC
has,
emulation running in the FPGA.
It has, the FPGA board here is running both the AGC and the monitor that I built in a single bit stream.
So you have It has been upgraded. That's,
Yep.
that's V2 of your AGC emulation.
Yeah, and then the rest of the board here is implementing 24 C-type circuits for AGC-I/O, 8 D-type circuits, an R circuit, and then we have a potentiometer here that simulates the numerics dimmer in the command module or the lunar module that'll let us turn the brightness on the EL display up and down.
Woohoo! And then you have a big connector and you've made a cable somewhere.
Yeah, so I built...
Your favorite.
Yeah, I built this cable. I cut a D-sub 50 cable and wired it into a little SLA printed stand-in for this connector since we're unable to find a real one.
Well, that will do for me. Deutsch connector Ersatz.
Yep.
All right. So let's power supplies on that. You told me.
Yeah. So I didn't put any power supplies on this board directly. So it
Yep.
has a bunch of banana jacks.
Right.
It takes in 28 volts for the relays. 14 volts is used for the EL display. 5 volts is used for the caution and status lights, and then we're not going to wire it up today, but there's a 75 volts AC that powers the key backlighting.
Yeah, that has faded, unfortunately.
Very faded, yeah.
All right.
Moments later.
Okay, so we have UAGC, which is running. I saw it running a second ago.
I just halted it so that we can see what used to be on the display before we change it.
Oh, so when it come up, it will have the memory of the relays, of course. Right?
Exactly. So let's start with 5.
5 and 14 come at the same time.
Okay, then
you do want.
don't do that then. We want 28 first. 28 comes before 14.
Okay.
Okay.
All right. And I can just unplug it if you want to do one at a time. Which one do you want next?
The next doesn't matter. It's just 28 should come before 14.
Okay, then we have 5 and 14.
Okay.
Huh?
So I'm going to run a test really quick where I write...
So it had nothing on it.
That's correct. Yeah, it had nothing on it. Kind of anticlimactic. It did have a program alarm though.
Huh.
So if I write bit 7 to channel 11, there's an operator error.
Is that what you expected?
Yeah.
Oh,
That's what I tried to do. I just to test the relays. It's just a
So
really
it's-
quick little test.
it's working already.
Yep, there you go. Operator error. Turn that
Okay.
off. And load. Okay. So I'm just gonna let it run. We got a restart light. That's good. And proceed.
Whee! It's a working disky.
Sure is.
1665. Oh, what are you entering things on your keyboard?
Yeah, that's a good point.
You have a much better one over here. Verb 34.
So that just kills the display I put up. I can do a light test. Well, we're running out of current on the 5 volts there.
Okay, I can give you more current. I can give you more current. I limited you just to be on the safe side. Here you go.
Should I try it again?
Yeah.
Nice.
Wow.
If only we had an AGC to run with it.
That's the first time that keyboard's been used for an AGC-related function in quite a few years.
Yeah. So I can. The other thing I can do.
I don't think anybody has ever relighted in a disky.
Yeah.
I'd say we're the first ones to
Yep.
do it.
So I'm gonna do a Verb 21. I'm running Aurora 88 right now.
Uh-huh.
Lunar Module System Test Rope. So this has something that the flight ropes don't have, which is if I load an 11 into Verb 21, now 27, we're going to get the disky test, which will run through all the digits and all the positions on the EL display.
Cool. So that was not part of flight. You
Right,
said.
yeah. The Verb 35 that I did that lit everything up with all 8s and then all those lights, that did persist, but this mode they took out really early.
And it's fairly bright in here. I have like 2 cinema lights and the lights. And...
I mean, that we can also turn up the brightness and down the brightness with the dimmer here.
Oh.
It actually gets pretty bright.
Yeah. Yeah. So you know what? It's our power supply on the block 1 thing that is just was getting wimpy, was failing. Actually, I could turn that as it's up. I could probably turn a few of my lights down.
Oh wow. It's in the plus and minus.
Mm-hmm. And then this is the last thing that it does.
Nice.
That's great.
So the other thing to note is that because I'm running an old rope, the update rate of the display is a lot lower than for the flight ropes. So if I load instead, oops, I'm going to load Skylark 48, which was the last AGC program. This is what flew on the Skylab missions NASTP, which I just got from the New Mexico Museum of Space History recently with the rope reader. Boot that guy up, and now our display should update much faster that we're running later software. Yeah.
Wow. That's a nice upgrade.
Yeah, it's super bright. See if I can get the lighting right. Right.
So is the compactivity light gone on?
It should do. It should flash when. Yeah, that doesn't appear to be working. So I might have a contact that's not pushed all the way in.
Oh, you mean the activity, computer activity?
Yeah, that's a good catch. That should be coming on.
Well, I guess we'll have to scrub the flight.
Which pin is that on? I'll have to look it up. What else can we do? A verb. Let me kill this. Whoops. Verb 34. If I do a verb 91, this is what calculates the checksums for every memory bank. So 4367 is the checksum for bank 0. It's summed up to all 7s, which is equivalent to the bank. It's either plus or minus the bank that you want that to be. And you can just hit proceed to go through.
Yeah, go it and listen to the noise. I think we weren't far off when we were running back there. I kind of slow it down to the most clickety, but it's very clickety. Wow, well, we have a disky that works.
Yeah.
Man, we repaired it. Well, we repaired it. Marcel gave us a screen.
You fix the button, 0 key.
Yeah, I did. Well, it's just because, and you made the AGC and blah 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 and blah blah blah, and you know the software. Wow, it's the mythical disky. Finally, I have a real one.
Mm-hmm.
Do you want to try to remote control it? You think you could do that, or it's just too hard?
We could do, but I don't have the right transformers here. I have to bring them next week.
What do you mean we won't control it? You mean
Well, yeah, so the idea, so the basically you can remote control the disky from the ground, right? From over there, from our box way over there. Should be able to control that on the moon. Woohoo! We have a working disky. If we were Usagi Electric, we would have done a big dance of victory here. But it's not 100% working. The comp activity light, the big square light in the upper left corner, is not working. And Mike and Eric went straight at trying to debug that.
More moments later.
Alright, second time is a charm. And then it's the button in the middle for the both supplies.
Alright, so let's pull up.
Sorry, I screwed you up, Mike. You're allowed to use your computer if you want.
Still no luck, huh?
Still no luck. So, the one... here's the thing, right?
So no
Is
computer
that
activity light.
We have
should
the
be
yellow
like
dot on
this
this
back
DSKY,
there.
and then one of the IDMs had a yellow dot on it. So maybe the comac relay is bad if that relay is in that module that had the yellow dot.
Oh, it could be that we found the fault that this guy had.
Maybe.
So Marcel paid all this money and it doesn't
And
work?
he doesn't get a comac light.
Dang.
Maybe, I don't know.
Mike and Eric debugged it some more but could not find anything wrong with the wiring. But oh, what fun it is to have a working DSKY in the lab when you know how to use it. What are you trying to do?
Noun 09 to look at our program alarm. I made a 1202. So the reason that works, I turned on the inhibit hardware alarms on the monitor. And then if I do a verb 69, well actually, let me turn that off first. Verb 69 is the way that you cause a hardware restart. So this puts the computer into an infinite single instruction loop, just a jump to self, which triggers the TC trap and causes the computer to restart. If I disable hardware alarms, so that hardware alarm can't kick in, and I do a verb 69, we're now in a single instruction loop, so it can't do anything.
Okay, so
but interrupts still work.
Uh-huh.
And so every time I press a key, whatever key, it generates an interrupt, which spawns a job.
Uh-huh.
And then it exits the interrupt, and we're still in the single instruction loop. So if I keep hitting keys,
you will reproduce the
we
the
run out of
table
jobs.
overflow.
And so the executive sees that and says, hey, I can't spawn a job, and causes a 1202 program alarm. So now what I'm going to do is pull up this erasable memory program that I wrote.
Oh, it's now your own program?
Yes.
What does it do?
You'll see in just a second.
Aha.
I'm going to do verb 21, noun 01. We're putting this into address 660. Okay, then noun 15. 4,000, 25, 1240, 5037, 54707, 5032, 54706.
Oh, you're just entering your program?
Yep.
In memory?
Yeah.
You're playing Kim 1
See the address
on the AGC, right. So you're...
Yeah, the address that I'm loading the data into is at the bottom. Noun 15 is an auto increment address.
So that's the address, and then the data you put in is what appears on top.
Mm-hmm. So if I did that right, we should now have a program loaded into erasable memory. So I'm going to do a verb 25, noun 26. This says in 10 centiseconds, start the program that is located at address 664 with, this is the bank information. I'm putting fixed bank 4, erasable bank 3. It doesn't actually matter. And then I do verb 31 to start my program.
Is this Pac-Man?
Not really.
This is blinking lights. This is chasing lights.
Waka.
Let me change address 664 to...
Your DSKY is misbehaving. You got the virus.
No, it includes the program verb and noun.
Yeah, just imagine if someone had
You made it worse.
what if somebody uploaded this to the astronauts and then
Yeah,
this place starts
exactly.
getting-
We could totally do it from the ground, right?
Uh-huh.
You just to put a virus in your diski.
just as Neil Armstrong is about to touch down.
Exactly, you just blank the diskies with 0 that chase and
If I go to a different program, it kills my erasable memory program, so it's not there forever.
You're a nice hacker, we know that.
I love that full screen redraw.
Yeah. Cool.
So something that just occurred to me, since several of the relays in the DSKY are for controlling external things like the ISS light, the CMC light, I think, and then there's the landing radar position. There's 2 relays that will control AGC control over the Saturn in there. Anyways, point is, all 6 indicator driver modules are identical, and we might be able to fix our computer activity bug by just swapping 2 modules. If we find one that has a relay that we don't care about in that position and swap it with a different module,
Ooh.
we could potentially fix it that way.
2 weeks later.
So Marcel, what are you doing to
We
your
are
beautiful DSKY?
opening up one of these driver modules that seems to be misbehaving.
Oh, the one that's not...
The one that drives the computer
drive-
activity light.
yeah.
So we're just seeing what we can see inside here. If anything's
Is that the
obviously-
one that's misbehaving?
Yes.
This one is, yeah. And this is one that we're anticipating swapping, so we can see if the problem follows the module. But we're going to take a look here since we got it out.
Ooh, nice.
Unexpected there too.
Yeah. I was really expecting this whole thing to be potted, but
Is that because this is not a flyable module? Or
Are these resistors, what are they for?
There's our wiring.
so there's resistors and transistors and stuff over here that are the relay drivers, and then this is just the bank of relays.
Okay.
Yeah, so this
So
is more
there's-
cordwood
Yeah,
structure.
there's 22 relays per module.
And the back is the wiring to the pins.
Yeah, and you can see there's 2 layers of wiring here too. The wires going this way, and then a sheet of an insulator, and then some wires going that way. It's beautiful.
It really is.
Well, there's 3 layers, I think.
Oh, and then there's a layer.
If you look there, there's a layer underneath the
Yeah.
horizontal.
Yeah, there's 2 sheets of plastic or something.
Super cool.
So were these soldered or welded?
Oh, welded, for
And-
sure.
And then they put a glob of stuff on each one?
Yeah.
And then this goes to relays, which is a scary thing.
Yeah, big bank of relays.
So we could probably figure out which relay is the problem.
See if it makes a noise.
Yeah. Well, I think it
Oh,
does.
it does make the noise, that we know.
It's-
Well,
It's
we
gonna
can try to
be-
make that one make the noise.
What's up with the blue?
Some like adhesive or something.
Relay fungus?
So I think it would be. Yeah, I mean it is these one of these 2 relays is responsible for computer activity.
A little longer than a few minutes later.
You fixed it!
We fixed it.
What do you do?
So we swapped modules D4 and D5. All 6 of the indicator driver modules are identical.
The relay modules
Yeah.
that you just opened.
Yep. They contain 20 latching relays and 2 non-latching relays each. The computer activity light is controlled by one of the non-latching relays. So we have our schematics here. Module D4 is at the bottom here. its two non-latching relays are used for the computer activity light, which wasn't working, and ISS warning, which is another light controlled by the DSKY, but not on the DSKY, it's on the warning panel.
Okay. So yeah, there's a few extra relays that couldn't stick anywhere. They stuck on the DSKY.
Exactly.
Right?
Yeah. The other module that we swapped it with, module D5, is a perfect example of that. That controls the standby light and S4B injection sequence start, which is a relay that you can use to command the flight control computer in the Saturn V to start the TLI sequence to go to the moon.
Wow.
Which is, just
important relay. You want that one to work?
Yeah, and you put it in the DSKY. Unfortunately, we just moved our bad relay there, so we can't do our TLI injection sequence start.
So, but that's probably what was the yellow dot for it. Is that relay didn't work?
No, we didn't change the yellow dot. We don't know what the yellow dot is for. But yeah, it was not the yellow dot relay that was affected by this.
So it's a lot louder, it seems, with the cover off.
Yeah, it is.
It's loud either way, then.
Because you hear the relay.
So we switch these two.
Right, yellow dot's down here.
Ah.
So this is D1. All of the digits are working from D1. So if it is a relay problem with D1, then what would not work is operator error or flash, and both of those things work. So I don't know what's wrong with D1.
Do something that makes it calculate really hard, like a P63 calculation or something like that?
Yeah, I can get a P63 queued up. Give me a second. Gotta switch ropes.
Program 63 is of course Pirate Descent Initiation, or PDI, the big moment when you start the landing sequence on the moon and start up your descent engine.
Okay, so we should be able to get into P63 now.
And so that should make the thing calculate hard. Yeah. Then we have the computer activity light. Yep. Oh, we have a fully working DSKY. And it's thinking hard.
Yep, lots of thinking for me. Ignition algorithm.
There you go. 2 minutes 13 from ignition.
Yeah.
Flight guide.
Go guide.
Did you get his TIG is real good in P63? 700 to the second of Roger.
This screen is our burn attitude with the 3 target attitude angles. Pressing proceed will orient the LEM to these angles.
Enter.
Then we have a few warnings that our switches are not right, we don't have them connected. So Mike is just going to enter past them.
Okay, all flight controllers, go for powered descent. Retro? Go. FIDO? Go. Guidance? Go. Control? Go. Telcom? Go. GNC? Go. Ecom? Go. Surgeon? Go. Capcom word go for powered descent.
Propagation of the state vector before starting average G up.
Oh, 1 minute 22.
Yep. We'll get a display blank at T-minus 35. And then a flashing 99. And
flashing 99, and you have to do pro.
Yep.
And then on the comms you have to do 99 pro. Looking good.
It's like watching a microwave.
Do you want to do it, Marcel?
Sure.
Once it gets to T-minus 5 seconds. So here's the blank.
Arm defense.
Okay, all flight controllers, 30 seconds to ignition.
Give it a nice... Proceed is a weird key because it's not interrupt driven like all the other keys, so you have to hold it in for just a little bit to make sure the computer actually registers it.
A little manual debounce.
Yeah.
Alice?
1.
6, 5, flashing 99. Go for it, proceed.
0.
Yeah.
Ignition 10%. Eagle Houston, everything's looking good here, over.
Ignition. Glitch.
Delta V monitor.
Ignition, we failed. You didn't ignite. It's because you haven't bought the engine yet. Now, of course, he's complaining that he didn't feel any braking because Marcel didn't bring us the engines yet. Still, what fun it is to ride in a one DSKY sleigh. There is one more thing I really wanted to do since we just had the Apollo comms up data link working. In theory, we should be able to use that to remote press the keys on the DSKY from Houston. Let's give it a try. So Ken is dressing up. We have the proof that he doesn't wear the coat all the time. So we were preparing to show our latest and greatest. Mike, explain what you've done.
I have used a little breadboard here to connect the updata link to this AGC, which is connected to the DSKY. It has two little pulse transformer Y circuits on it that are able to receive transformer coupled pulses in from external devices to the Apollo guidance computer.
Mm-hmm.
The updata link puts out one pulse if it receives a 1 and a 0 pulse if it receives a 0. So that's what these two transformers are, the 1 transformer and the 0 transformer.
Simple but efficient.
Mm-hmm.
Then on my side, I have made a tape to control the AGC, and also we have added some piece of equipment because we're probably going to send this whole setup to a museum, and we might not be able to use the original transmitter. So we have an HP transmitter and an HP receiver here for the sound. But apart from that, I'm going to try to send you some stuff. Let's see if I can see it. So first it reads the command, and it will send it up the next time I press. Okay, so that's the, I can't remember which AGC command that is, but I made a whole tape that'll get the lights going. So
One of the first ones is probably reset.
So I'm going, and I can't remember exactly what it does, but I think you're right, it first does reset. And then it lights a light.
Yeah, uplink activity.
Okay, uplink activity, that's good. Then I input a 3, a 5,
Oh, there you go.
and that's what's verb, and then it launched the setting.
Yep, verb 35 enter.
And I think then I go in 2, so it should be,
Verb.
that's another reset.
Oh yeah, reset. Verb.
That's 3, 7, then I do the noun, 0, 0, so that's go to program 0, 0, and I should input. There you go. Wow, so that's our grand achievement of the Apollo communication system. All this to show that we can control the well, if you can control the AGC, you can do a lot of things. You can orient the spacecraft, you can do burns with this little bit of equipment. Well, that was a great feeling to have all this Apollo hardware work together again. Like many Apollo enthusiasts, it had been a dream of ours to restore a real DSKY and get it to work again. But despite our best trying with renowned museums that have many and the highest recommendations from former Apollo program directors, we could never get our hands on one. So before this one inevitably goes to rest in a museum, we wanted to share the joy of a working DSKY and briefly exhibited it unannounced at VCF West. Mike and the team also gave an impromptu talk with a live demo to boot, thanks to Eric Klein, the VCF organizer, who let us slip in at the last minute. We'll never be able to thank Marcel enough to let us and others enjoy a working DSKY. But we plan to do more with it, so stay tuned for the next episode. See you then!
Almost certainly. So now we have 46 seconds to go. I can look at 1703 is our program alarm,
Okay.
but it's fine. The blank at minus 35 means average G has now started.
Okay.
It's going to start accumulating our velocity. I can go ahead and dismiss that program alarm.
Well, this is our altitude?
That is our velocity.
Velocity.
In theory, once we hit 0 and the engine turns on, this should start
Decrementing.
decreasing. But we don't have an engine, so we're not going to sense any acceleration. So it will not.